And the main story here is, if you get nothing else out of the talk today, it's all about the tides. Tides, tides, tides. Tides drive so much of the transport within the delta. As an example of this, from my colleague at USGS, Lisa Lucas, I have an example here, so I'll start showing this video. The video here is to demonstrate for you the importance of the tidal motion. And so on this video, there's a red dye being continuously released up at Verona, which is off the map here, so you now see it coming down the main stem of the Sacramento River. This is for an October low flow. The Delta Cross Channel located here is open, so water is moving into the central delta fairly quickly. Each frame has a 2-hour time step to it, so each image is separated in time by 2 hours. And I want you to focus on sort of the leading edge of the red dye coming down through the Sacramento River to see all of the tidal variability that takes place on a typical tide. For this simulation, there is pumping taking place down in the south at Clifton Court Forebay, so there is a net flow down to the southern delta. Things you may want to notice, for instance, the upper Sacramento River here, you can see quite a bit of tidal variability as what's now a sort of yellow plug of dye moves up from Liberty Island down into the lower Sacramento River with each tidal cycle. So again, quite a bit of tidal motion. This is what we know as the tidal excursion of several kilometers, water moving back and forth. Each change of color, the color you can think of as representing a concentration. So if you go out to collect a water sample, for instance, in the lower Sacramento River, sometimes the water is the light blue, sometimes it's sort of an orange reddish color. And that represents changes in concentration that take place over just a couple of hours. So this is one of the challenges of collecting data in the delta, is that the tides change the concentrations tremendously over the course of a few hours. So you can get a water sample, and a couple hours later you may have a very different concentration at that location. Other places you can see some variability is here at where the Mokelumne River comes into the San Joaquin. There's quite a bit of mixing that takes place at junctions. I'll talk more about this in a moment. But the key junctions, like the 3 Mile Slough and the Mokelumne River coming into the San Joaquin River, you can see here sometimes San Joaquin River pushing up into the Mokelumne, sometimes Sacramento River coming out of the Mokelumne into the San Joaquin. So again, quite a bit of action takes place at these junctions. With the pumping taking place in the net tidal flow, you can see now this some of this dye from the Sacramento River has moved into Clifton Court Forebay, and also the pumps coming through the Old and Middle River channels. And as you look down there, even in this simulation, well, I've been talking too much, but as you could see that dye moving down through the South Delta, there was also quite a bit of tidal variability taking place down in the South Delta. So this is throughout my career, several times, I don't mean to pick on chemists, but sometimes chemists will say, gee, we went out and collected some samples, and we went back a day later and it's completely different, and gee, it seems like these tides are important. And yes, the tides are very important for collecting the water samples. So if you get nothing else out of the talk today, just the importance of the tidal motion. I would say in the last 10 years, this appreciation has grown.